Alrighty, I'm going to make a short, quick video on some CAN bus systems, showing CAN bus being shorted to ground, shorted to power, and shorted CAN high to CAN low. So this is a 2007 Chevy Tahoe. It has GM LAN, or General Motors Local Area Network, which is the same protocols as CAN, meaning there's CAN high, the green tracer, CAN low is the red tracer. The bias voltage is 2.5 on both high and low. Bias voltage meaning recessive state, don't do nothing. Then the message goes high from 2.5 to 3.5 roughly. And then the low goes from 2.5 to 1.5 roughly. Differential voltage of 2 volts. They twist these wires in a pair. Got my breakout box hooked up. I'm on pin 5 on the DLC for ground. I piggyback my grounds. Got CAN low there and CAN high there. Or CAN low, CAN high. And just to show you this, obviously these are the messages in there. But if I'm on the green one, the bias voltage is 2.5. The red tracer, the bias voltage is 2.5. So that is a good message. So now what I'm going to do is show you some serial decoding. I'm going to turn off channel B. There's CAN low. Going here, serial decoding, enabled, CAN low, and we're going to serial decode it. So these are all the messages here. So what you could do is you could freeze this. You can measure from like here, sorry about the glare, to there. You can find where it starts and stops at on the time. Yeah, right there, 4.2 to 4.3, roughly. That's that message. And you could decode this message. Here's your hexadecimal ID. But obviously what this is showing is there's a message. You can also go back from doing hexadecimal. You could do binary. And it'll have your zeros and ones right there with your 11-bit identifier. So we got messages there. But now what I want to do, well, turn my serial decoding off. Put my other channel back on. Move this one over here. And then what I'm going to do now, since obviously I have key on engine off, I'm going to take and jump the pins. I'm going to jump CAN low to pin 4, which is a ground. That'd be the same thing as doing it on the DLC. So I'm going to jump that right there. And you can see when I did that, it corrupts the message. Service track, stability track, ABS lights, and all kinds of stuff is going on. You can hear it ding in there. So if I take it off, it goes back. We're on a 2 millisecond time division. I'm going to do it again. You can see it. Really hashy, really noisy. If I freeze this, my bias voltage here, I'm on the green one, which is going to be down in here, 168.4 millivolts. Which is short to ground. And then the other channel is, you can see the center there, 664.5 millivolts, short to ground. So what it does to one, it does to the other. What did we do there? We shorted CAN low. We were on CAN low, which is pin 14. We shorted to ground. If I unplug it, it goes back. Obviously, we're going to throw a bunch of U codes in these computers on this car. Now, what I found interesting is, if I take this one off, so I got this one off, and I go to CAN high, and I short it. Look at that. That's CAN high shorted now. But if you notice, There's some messages there, but it's lined up on both. So we are on, let's go to the green tracer, which is channel B. 90.4 millivolts, which is short to ground. Go to the other one, the red one, 162 millivolts, short to ground. Now we are on, like I said, we're on CAN high, shorted to ground. A lot cleaner signal, but you can see there's some messages in there, right? But obviously, it's not communicating or nothing. Now, what I want to do is I'll unhook this. Goes back to normal. Let's just turn channel A off. Let's put our surety coding on for CAN high, because that's what we're on. So we got our messages there, hexadecimal, right? Good. Now let's just short it. We're going to short CAN high, because we're in CAN high. Short it to ground. And look, the messages go away, because there's no COM. There's no surety coding going on, because there is no messages. Take it back off, it does the same thing. Well, now let's just move this to, let's move this one to CAN low. Even though we're just reading CAN high, short it to ground. Of course, it's going to take both of them down, but there's no messages. Real hashy though, right? Just like we showed before. So what it proves there is what you do to one channel. Let's turn the other channel on. Or one, not one channel, but what you do to one CAN wire, it does to the other one. So turn this back off. Guess we can do both surety coding. It's not going to matter because they're both not going to have COM. But what you do to one, it does to the other automatically. It takes them both to ground. What I found interesting though, like we're in CAN low now. If we short CAN low, real hashy. 0 volts, 0 volts in the center there, 0 volts in the end there. But if I move the other one to CAN high and short it to ground, a lot less hash, but you can see the messages, what it does to one, it does to the other. So I found that interesting. So just we got to remember now that CAN high is the cleaner signal when it's shorted to ground. So now what I'm going to do is short it to battery positive voltage. Ground, pin 16 is your battery positive. I'm in CAN high, which was a clean signal compared to low. So high we're in. Oh, hold on, I gotta switch this. Sorry. I gotta go CAN high, shorted to positive. So CAN high, shorted to positive. CAN high earlier was a good waveform. Not good. It was cleaner than the CAN low one as far as noise. Shorted to battery positive voltage. Opposite, right? It's real noisy. Let me change my scaling though. It's one battery voltage. That's what we're going to. Let me get this scaling set up. Already got my scaling set up. So again, we're taking CAN high to battery positive, which when it was shorted to ground, the waveform didn't have as much hash. But now it's opposite. We're going to have a bunch more hash. There's CAN high. Do it again. I got to get my scaling right. Hang on one sec. There, now my scaling's better. Try it again here. It was only going to like 5 volts here for a sec, which is weird. I'm going to battery positive. So that's CAN high to positive, then it just switched. I just missed it. Do it again. So normal, CAN high, going to battery positive. Well, it goes to 12 volts there. If we freeze that, for a couple of times there, I caught on camera, I was going to 5 volts. That's why I didn't expect that. So there's green, roughly 12 volts, a red channel, going up to 12 volts, 11.9 roughly. Just play it again. Let's do it again. Yeah, it was weird because earlier back here it was at 5 volts. Your green, and it stayed there for a little bit and then it jumped up. Yeah, 5 volts, even though we're going the battery positive. The red, yeah, it's all over the place. It's only showing millivolts there. Let's do it again and check. Can high to battery voltage. Same thing, shorted. Your 12 volts on the red, 12 volts on the green. So now what I'm going to do is I'm going to change this and short out. I'm going to short out can low to battery positive. And look, it's a lot cleaner, opposite of what we had for the other one. So if I freeze this and I measure the green, 12 volts, and I measure the red one, 12 volts, 12.3. So what you do to one, it does to the other. The only difference we had there for a while kind of got me off guard is it would go to 5 volts. Once in a while, then it would go to 12 volts, even though it was going to battery voltage. So it's interesting to see the difference between the channels. So to do that again, just to show you, let's set these back to 10 volts. And get the scaling. And let's do it all over again, just quicker this time. Can high green, can low red. What we're going to do, I'm going to start with can low go in the ground. Watch it. Can low and go in the ground. Really hashy, really noisy. 0 volts there, 0 volts in the center, or 100 or 200 millivolts. And then I'm going to do can high to ground. Now it's good. Now make it bad. 0 volts, or roughly 100, 200 millivolts. Lot cleaner signal. Now what we're going to do is do can high to positive voltage. And it's going to be messy, which it is. My other channels, well, I got to move these scaling because we're battery voltage. 12 volts there on this side, 12 volts there on this side. Now it's can high to positive. Now let's go can low to positive. And then 12 volts on the green, 12 volts on the red. So it was opposite of the power, short to ground, short to power. What's interesting though, get this back scaled back right. Get this set up here. Unplug the channel. What's interesting though is, well, it's all good now, but what's interesting is what you do to one CAN wire will do to the other CAN wire. Obviously, because the wires are connected and they terminate in termination resistors. One end is 120 ohms, the other end's 120 ohms. They run them in parallel and you get 60 across the bus, pin 6 and 14. But show the footage and the data here. One's real, when you take one to ground, one's real hashy messy. The other one is same thing. Or one's real hashy messy, while the other one is not. And it's opposite when you do to battery positive shorted compared to battery ground, or battery ground, yeah. So I thought that was very interesting to see that data, why they would be different than that. But I think it could help troubleshoot. Oh, you know, you've seen like a real, depending if it's short to power or short to ground, that could help you determine which wire is actually shorted. But either way, they both bring them to ground. However, there's one anomaly in this. I saw when I was filming, and when I shortened to battery voltage, they go to 5 volts for a little bit, and then it went up to 12 volts. It was, never saw that before. This is only second, third time I've done this to look at this, but found that pretty interesting. One more test. So we got can high, can low. I'm going to short can high, which is here, to can low, and see what they get. Clean signal, not clean, but cleaner than the other ones. Got your messages there. Let's freeze it, and let's see where we're at. So the green one looks like 2.5 bias voltage. Boom. The red one, yeah, 2.5 bias voltage, right? So I unplugged it now, but that just shows can high shorted to can low. Now I'm doing this all on a breakout box. I'm using a ground off of the, you know, through the breakout box. May have some anomalies there. I may make another video where I show it later on. I'm just running out of time today, where I show it going from the actual battery positive, or actual battery negative, to short to ground, and battery positive short to positive. Try with that, try with different scopes and so forth. But I just found this pretty interesting. Well, I'm not going to use another scope, but I'm going to take it from battery negative and short it in battery positive. So right now I got a wire going to battery negative, running across, and how I'm going to do this, I got my scope playing. I'm going to take my jumper, my little T-pin, and back probe can low, can high to ground, and see what it does on the scope. Right from the battery, do the same thing for positive. So let me pause this while I hook this part up. All right, so I unhooked it so it's easier to get to. Got it plugged in. I'm on pin 6, which I don't know if you can even see that or not. It says 6 on there. Yeah, pin 6 on back probed, which is going to be can high is pin 6, which should be a good message from our earlier results. Not good, but I mean less hash. And there it is. So let's freeze it. And let's take a look and see where we're at. So let's go to the green one. And we got, yeah, 9.9 millivolts. A lot better of a ground. I just moved it there. But it was a lot better of a ground. The same results as far as that. Go to the red one. Yeah, 10 millivolts. So, because you're actually going off a true ground. Now I'm back to normal. Now we're going to ground. That was can high. Now we're going to ground can low, which is pin 14. I'm on pin 14 now. The back there. See a back probed, which is can low, pin 14. And you can see your hash. Let me freeze that. You can see here 2 point, I have to go on the green one. You know, 29.4 millivolts. A lot more noise though, just like we had on the other one in the middles. Well, hell, it's actually up there. It's hard to kind of tell. But if I play this, I actually zoom in now, you can see the red is right there. Yeah, roughly in there. It says negative 68 millivolts. And then the green down there is your 0 right there. But this again is on can low, yeah, pin 14 on the back there. A lot more hash, obviously, compared to the other one. Now we're going to go to battery positive. Let's go back to our scaling here. I'm going to go to battery positive. Let me pull this pin out. It goes back to normal. Now let's do battery positive from the battery and do the same test. All right, so I got it to battery positive. My lead. We're good there. Now I'm going to take it to can high again, which is pin 6, and I would imagine it's going to be opposite of the other one, short to ground. Obviously going to go to power, but it's going to be less hash. Or sorry, I mean more hash. So I'm on pin 6, which is can high. I'm on pin 6 up there. And you can see we got to change our scaling again. But you can see it's a real hashy. So if I'm on green, hang on, let me get this set up. Let me change my scaling, it's easier to read. So let's freeze it. So green, short to power. I'm on the wrong one there. There we go. Hang on. I had my scaling set up wrong. Sorry. So I'm going to freeze that. Center that's 12 volts. Short to positive. The red one is going to go up to, 11.7, 12 volts. Short to positive. It's just easier to see with that scaling. So that was pin 6, which is can high. Now we're going to go to pin 14, which is can low back there, and I would imagine it'd be less noise, just like we did earlier in the video. But we're going right from the battery. And then pin 14, which is can low, less noise, obviously a corrupt message, just like any other one. If I freeze this, go to green, 12 volts. Go to red channel, 12.2 volts. So, and obviously it's not going to serial decode or nothing. Let me unplug this, message comes back. So again, like I said, I find this very interesting that, let me go back before I talk. I can only do one thing at a time. I find it very interesting what it does to one and does to the other. It takes them both to ground if you just ground one or the other, or it takes them both to battery positive voltage if you short to voltage on one or the other. Now there's different noises between the high and low when you're taking it to ground, and there's different noises between high and low when you take it to battery positive. So I just wanted to show that on video. Probably will help troubleshoot for future stuff as far as, if one is real noisy, if it's short to voltage or short to ground, you can determine if it's the high or the low, or vice versa, many combinations. So that is it for this video. I know I said I was done. I want to do one more test. This time I took the breakout box out of there, and I'm just probing into there with some breakout kit from AESWave.com. I got my ground and pin 5 piggybacked. I got can high, can low in here. Hooked up to my scope, no breakout box. Right there is can high, can low. And I'm going to take my my wire and go into battery ground, doing the same thing. And I'm going to back probe it on the back of the connector and see if we get the same results. All right, so I got it probed on pin 6. You can see it there. Pin 6 back probed, which is can high. And same thing Obviously not communicating, but a lot less hash. So if I freeze that, let's go to green, let's check it. Yeah, pretty much zero, you know, 7.4 millivolts. Zero, right? Go to the red one. Same thing, 25 millivolts, good. So now let's do CAN low pin 14. I'm in CAN low, which is pin 14. A lot of hash, just like before. Let's change the scaling. Freeze it, green. Bottom of the waveform, you know, 0 volts, red. All I'm doing this is just to get rid of the breakout box wiring and stuff. So 0 volts, right? So pretty much the same results there. Now let me do battery positive. Let me take this out, make sure everything comes back, which it does. Now let's go to battery positive. Battery positive hooked up. Let me get my scaling set up first. There, I'm on 20 volt scale. I'm going to take my battery positive and short it to CAN high, CAN low. I'm going to go to CAN high first, which is pin 6, which I would think this one would have a dirty waveform because it's opposite. I'm on pin 6, which is CAN high. I would not want to touch it to battery or to ground. That would, because I have no fuse in here, that'd be bad. But you can see it's dirty. Change your scaling, pause it, green, 12.2 volts, red, top of the waveform, yeah, you know, 11.5, 12 volts. Depends what I'm measuring at. So now, let's unplug it. Good to go, came back to normal. Now that was CAN high, now let's go to CAN low, which is pin 14. CAN low, pin 14, to battery positive, off the battery. A lot cleaner waveform. Still no messages, obviously. We freeze it. Go to green. Let's check it. Center 12 volts. Red. 12.3 volts, same thing. So now let's unplug it. Waveform comes back. So now what I'm gonna do is I'm gonna reset my scaling up and short CAN high to CAN low in the back of the connector. And all we're doing is eliminating the OBD breakout box from all this. Now I got my wire in looped. Just jumped CAN high to CAN low in the back of it, no breakout box. You can see the message, it can be 2.5 bias voltage. Green is, just go back so you have some numbers. Green is 2.5. Red is, God. Oh, come on. .5. So that's just CAN high to CAN low. You unplug it. Everything comes back. So pretty cool results there with all this stuff, with the breakout box, without the breakout box, going at the DLC, going at the battery for all this data. What I'm gonna do now is plug in the VCI and show you all the codes it threw from doing all the short to voltage and short to power and so forth. So for the last part of this video, key on, engine off, VCI hooked up, doing a full system scan. You can see there's a bunch of codes. Before I did all this, all these computers had no faults. Of course, we're going to make faults. I just want to show you what faults are created from short to ground and short to voltages on the CAN bus, or shorted CAN high to CAN low together. All right, so it's almost done there. So let's go to report. So the engine has control module bus off, lost comm with DCM, lost comm with transfer case, loss come with ABS, loss come with BCM, transfer case control module, bus off A, loss come with ECM, EBCM, BCM, transfer case module, bus off, loss come with BCM, loss come with ABS, loss come with TCM, loss come with ECM, PCMA, EBCM, loss come with BCM, loss come with ECM, PCMA, loss come with transfer case, loss come with TCM, control module, communication bus off. So you can see that it created a lot of U codes from that, what we did there. So I'm just going to erase all these. Everything will be good because everything's hooked back up. But that is it for showing this CAN bus system, shorted to ground, shorted to voltage, using a breakout box, using a not breakout box, at the DOC, at the battery, and so forth. So that is it for this video.